boys and girls, in this video we will solve some problems in indices, which is also called powers and exponents. Okay, either indices or powers and exponents, both are same. Okay, so any number that is written is said to be written in indices form when it has a base and also has a power. Okay, for example, if we take 4 square, like 4 to the power of 2, which means the base is 4 and the power is 2. Okay, so this whole number is written in indices form. Okay, similarly this also, the base is 4, power is 1 by 2. Okay, so this number is written in indices form. Okay, there are 4 problems on the whiteboard. Let's solve one by one. Okay, simplify the following using powers and exponents theorems. Okay, the very first one is 4 square into 4 to the power of 3 or 4 cube. 4 square into 4 cube. 4 to the power of 2 or 4 square into 4 cube. How do we simplify this one? So there is one theorem in powers and exponents, that is x to the power of a into x to the power of b is equal to x to the power of a plus b. Remember, there is an into here. Okay, it's not a plus, don't confuse. But here it is not an into, it is plus. That is one thing. Second thing, for both these two numbers, we have the same base, that is x. That's also important. And here also the base should be x, the same base. The base here should be the same, and the base here also should be the same. Alright, yeah, let's go back to here. So this is a theorem. X to the power of a into x to the power of b is equal to x to the power of a plus b. So what is x here? 4 can be considered as x because here the base is 4 and here also the base is 4. We have the same base in both the numbers, and there is these two numbers are getting multiplied. So this theorem can be applied here, which is equal to 4 to the power of 2 plus 3. 2 plus 3. Isn't it? Okay. And then if you further simplify, 2 plus 3 is going to be 5. 4 to the power of 5. 4 to the power of 5. You can leave it like this, or if you want to simplify, you can further simplify it, because here it is asked to simplify. That's fine, you can do it. 4 to the power of 5 is equal to 4 into 4 into 4 into 4 into 4. 4 4s are 16. 4 into 4 into 4 into 4 into 4. 4 4s are 16. 16s are 256. 256 into 4. I think that is 1024. Okay, so 1024. 1024 is the answer. Okay, so we solved this, the first one, the first part of the part A of the first sum. Okay, is that clear? So immediately, if you see in this pattern, you have to, this idea, you should get this idea. Okay, this theorem should come to your mind. Then only you can apply it. So there are few theorems which we already discussed in the previous videos. This is one of the theorem. X to the power of a into x to the power of b is equal to x to the power of a plus b. Okay. Why we applied this one? Because the bases are same and there is these bases are same for both these two numbers, and these two numbers are getting multiplied. That is why we applied this theorem. Alright? Yeah. I'm going to erase it so that we get some space here. Similarly, the second one is also the same. Like the same theorem we can apply here. X to the power of a into x to the power of b is equal to x to the power of a plus b. So which is equal to 8 to the power of 9 plus 2. The bases are same. The same base comes here, and these powers should be added because there is a multiplication here. Remember, there is in this theorem, x to the power of a into x to the power of b is equal to x to the power of a plus b. There should be a multiplication here between these two numbers, and here the indices, sorry, the powers should be added up. So the same thing, the same theorem can be used here also. So which is equal to 8 to the power of 11. So which is called a very big number. So you can use your calculator to simplify it, or you can even leave it like that. Okay, that's how we simplified it. There are two numbers. We clubbed it. We did some operations using the theorem, powers and exponents theorem, and we written as a single number. Okay, written as a single number in indices form. So this is about the part B of the sum. Similarly, here also the bases are same, and these two numbers in indices are getting multiplied. This is number in indices form, this is number in indices form. These two are getting multiplied. So the answer should be 5 to the power of 3 plus 2, which is equal to 5 to the power of 5. Okay. Again, this is going to be a big number. Yeah. And yeah, you can leave it like this. Okay. There are two numbers in indices form. We simplified it and we found out a single number. We simplified it and we made a single number in indices form. Okay. That's how those three parts of the first problem we solved it. Okay. Let's go to the second problem. Okay. If 2 to the power of p into 2 square is equal to 8, write down the value of p. Okay, so 2 is known to us, this 2 is also known, 8 is also known. These are all known quantities. Okay, these are constants. Their values are fixed, like 2 is 2, 2 is 2, 8 is 8. Okay, only one thing that is not known to us, that is p. Okay, the question asked here is to find out the value of p. Write down the value of p. Okay, let us solve it. So the same theorem, x to the power of a into x to the power of b is equal to x to the power of a plus b. The same theorem can be applied here. Okay, the same theorem can be applied here. So let us evaluate this one. Let us evaluate the left side of it. Okay, I am going to write down that equation here. 2 to the power of p into 2 square is equal to 2 to the power of, is equal to 8. Okay. If I apply this theorem, on the left side you will get 2 to the power of p plus 2. Isn't it? These are two numbers in indices form, and these two numbers are getting multiplied, but both these numbers are in the same base. So the powers can be added up. Okay, so we got 2 to the power of p plus 2 on the left side. On the right side, what do? We have 8. Can 8 be written as 2 to the power of something? We can write it, right? We can write it 2 cube. 2 cube is 8. See, why I have written it like that? Because if two numbers in indices form are equal, and if their bases are equal and their powers are automatically become equal. For example, if I say x to the power of a is equal to x to the power of b, both these numbers having the same base, so the powers obviously will become equal. A will be equal to b. Okay, something written like this, because here it is x and here also it is x, so obviously it becomes equal to b. A is equal to b. That is why I have written 8 as a power of 2. Okay, so if I write 8 in indices form with the base 2, if I write like that, then I'll get 2 cube, isn't it? 2 cube is 8. 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Okay, so now we have the bases on both sides are equal. 2 is equal to 2, and the powers obviously should become equal. So what are the powers here on the left side? The left side, the power is p plus 2. On the right side, the power is 3. Okay, so now we got some equation. Solve this equation. It's very simple. P is equal to 3, p here, 3 here, plus 2. If it goes to the other side, it becomes minus 2. Okay, in solving the linear equations with one variable, plus becomes a minus. If it goes to the other side of equal symbol, minus becomes plus, into becomes division, division becomes multiplication. Okay, so now p 3 minus 2, p is equal to 3 minus 2, which is 1. Okay, so this is the answer. That's what is asked here. Write down the value of p, that is p is equal to 1. Okay, yeah, again this is the place where you should get an idea why we should write this 8 as a 2 cube. Why why didn't we leave it like that? The reason why we written as a base of 2, as a base of 2, because we want to equate the powers. The bases are same here. The bases are same here, so that we can equate the powers. That is why we have written 8 in indices form with a base 2. Thereby we got a 2 cube. 8 is equal to 2 cube. Okay? Alright. Okay, let's move on to the third problem. Where is this one again? Okay, evaluate the following. First one is, part is 4 to the power of 1 by 2 into 36 to the power of 1 by 2. Okay, there is again another theorem in powers and exponents, that is x to the power of 1 by a is equal to x to the power of 1 by a is equal to 8th root of x, or I'll make it n. I'll put n here. Okay, x to the power of 1 by n is equal to nth root of x. For example, if I say 8 to the power of 1 by 3, this can be written as, what is n here? What is x here? 8. What is n here? 3. That can be written as cubed root of 8. Cubed root of 8, which is equal to 2. We know that. Okay, 2, if it multiply by itself 3 times, we'll get 8. Okay, so here also 4 to the power of 1 by 2 is equal to square root of 4. It can be written as square root of 4. You understand this part? X to the power of 1 by n is equal to nth root of x. Nth root of x. For example, if I take some number 8 to the power of 1 by 3, that is equal to cubed root of 8. Similarly, if I say x to the power 8 to the power of 1 by 5, then it becomes a fifth root of 8. Root of 8. Okay. Let us use the same theorem here, and we'll see how this can be simplified. So then it becomes, I'm going to write this one, x to the power of 1 by n is equal to nth root of x. Okay. So using this theorem, this can be written as square root of 4. Okay. Square root of 4. If there is nothing here, you can assume this is a square root. There is a 2 here. If you want to put, you can put it. There is no harm. Okay. This is square root of 4. Similarly here, into, what is this one? Square root of 36. Square root of 36. Okay, now it is simple. Square root of 4 is 2. Into, what is square root of 36? 6. Again, simply multiply this one, we get 2 6 are 12. Okay, so this is the answer. When we evaluate this one, we get an answer of 12. We got an answer of 12. Okay, yeah, that's how we have to do it. The second sum, let's take the second part of the third sum. Okay, it goes more or less the same way, but let's see what is the difference between this part A and part B. Okay, this one is 64 to the power of 1 by 2 minus 36 to the power of 1 by 2. As I said, x to the power of 1 by n is equal to nth root of x. So this can be written as square root of 64 minus square root of 36. What is square root of 64? It's 8. Isn't it? 8 8s are 64. 8 minus square root of 36 is 6. 8 minus 6, that is equal to 2. 2 is the answer. Okay. Here it is subtraction. You need to evaluate this first. Okay. Don't do any operation with this one and this one. Okay. Don't do any operation here. Okay. 64 minus 36. Don't do such operations, because this is the number that we have to evaluate first, and this is the another number in indices form we have to evaluate first, and then you have to apply this subtraction. Okay. Alright, so we solved the second part also. This is is another theorem. X to the power of 1 by n is equal to nth root of x. Okay, the fourth problem we have 8 cube whole to the power of 4. Okay, there is one theorem in powers and exponents, that is x to the power of a whole to the power of b is equal to x to the power of a plus b. Okay, this is another theorem in powers and exponents. So by applying this theorem, what do we get here? We have something, we have x to the power of a whole to the power of b. Such case, this can be simplified as x to the power of a into b. Sorry, it's not plus. X to the power of a to the whole to the power of b is equal to a into b. Okay, a into b. So 3 into 4. 3 into 4. Okay, and if you simplify this one, a to the power of 3 4s are 12. A to the power of 12. A to the power of 12. You can leave it like that. That is the answer. Okay. Similarly, the second part is also the same way. 7 to the power of 9 whole to the power of 5 is equal to 7 to the power of 9 into 5. X to the power of a whole to the power of b is equal to x as a base, and a and b gets multiplied. Here what is a? 9. 9 into 5. 9 5s are 45. 7 to the power of 45. Similarly, that one 18 to the power of 5 whole to the power of 8, that is equal to 18 to the power of 5 into 8, that is equal to 18 to the power of 5 8s are 40. 18 to the power of 40. Okay, so we solved all three parts of the fourth sum. X to the power of a into x to the power of a whole to the power of b is equal to whole to the power of b. Okay, this power b goes to the whole thing here. X to the power of a whole to the power of b is equal to x to the power of a into b. A into b. See that there is a difference. Previous one, the very first sum, what we did, x to the power of a into x to the power of b is equal to x to the power of a plus b. Okay, there is a difference, this one and this one. Here, these two numbers are getting multiplied. That is not the case here. X to the power of a whole to the power of b. Here, these two powers are getting added up, whereas these two powers are getting multiplied. These two powers getting multiplied only when we have a number in this form. Okay? Yeah. Let's take a few more sums. Okay, so let's take a fifth sum.
If 3 square
3 square
3 square 3
3 square
into 3 to the power of q is equal to 81.
81.
Write down the value of q.
Write down
The value of q.
value of q. Okay, find out the value of q. Okay, what theorem should we apply here? X to the power of a into x to the power of b is equal to x to the power of a plus b. That is the theorem we can apply here. Okay, so the left side you can simplify it using that theorem. So 3 square into 3 cube, 3 to the power of q is equal to 81. If I simplify this one using that theorem, x to the power of a into x to the power of b, you will get 3 to the power of 2 plus q. Okay, these two numbers in indices form, they are getting multiplied. When that thing happens, okay, the simplified form of it will be, is going to have the same base, and these powers will be added up. So that's what I did. These two powers I added, 2 plus q is equal to 81. Okay, so can I leave this 81 as 81? No, because when I'm making equations like this, I want to bring both sides, the left side and the right side, with the same base. Okay, I want to bring 81 also, I want to write 81 also as a sum number in indices form with the base 3, so that I can equate these powers easily. Okay, if I have something power here, then I can equate this one and this one. So 81, if I write as a base of 3, then it is going to be 3 to the power of 4. 3 to the power of 4 is equal to 81. How? 3 3s are 9. Okay, 3 3s are 9. 9 9s are 81. Okay, so now these two numbers, on the number on the left side, the number on the right side, are having the same base. What is that base? 3 is the base. Okay, so the powers will become obviously becomes equal because there is a equal to symbol here. Okay, so then 2 plus q is equal to 4. So if I solve this one, q is equal to 4. What do we have here? Plus 2 or minus 2? Plus 2. If it goes to the other side, it becomes minus 2. 4 minus 2 is equal to 2. Q is equal to 2. That is the answer. Okay. This is the unknown quantity which we found out by solving this. Okay. Let's take one more. Go on.
Show that
Show that.
4 to the power of 6
Okay.
divided by 4 to the power of 2 or 4 square is equal to 4 to the power of 4.
4 to the power of 4. Okay. This is also one theorem in powers and exponents, but here it is asked to prove. Okay. So what is the theorem? X to the power of a by x to the power of b is equal to x to the power of a minus b. Okay. That is the theorem. Okay. X to the power of a divided by x to the power of b, or you can say x to the power of a divided by x to the power of b is equal to x to the power of a minus b. If you apply the same theorem here, what do we get? How can we simplify the left side of it? 4 to the power of 6 divided by 4 to the power of 2 is equal to 4 to the power of 6 minus 2. Again, the bases are same here. There are two numbers on the left side. Those two numbers are getting, there is a division operation between those numbers. If such thing happens, this can be simplified as a number having the same base, whatever base here, x, the same base, and these powers getting subtracted. Okay, we have to subtract the power of denominator from the power of numerator. What is the power of numerator here? A. What is the power of denominator? B. So a minus b. So the same thing we have to apply it here. Remember, there is the same base here, x. Okay. Here there is a division operation, here there is a subtraction operation. Okay, so if I simplify this one, I will get 6 minus 2. 6 minus 2, which is equal to 4 to the power of 4. That is what is there on the right side. Okay, so we simplified it and we showed that. Alternatively, you can also do it. Alternatively, 4 to the power of 6 can be written as 4 into 4 into 4 into 4 into 4 into 4. How many 4s? Yeah, 6 4s are there. Here on the right, on the denominator, we have 4 square. That means 4 into 4. This 4 gets cancelled here. This 4 goes here. And what are we left with? 4 into 4 into 4 into 4. That can also be written as 4 to the power of 4. Okay? Yeah. You can do it that way, or you can, using this theorem, you can also prove that when you simplify this part, you will get a 4 to the power of 4. Okay, let's take one more.
Find x
Find x
in
in
8 to the power of 10
8 to the power of 10
divided by 8 to the power of 2
8 to the power of 2
is equal to 8 to the power of x.
8 to the power of x. Okay, so again the same term, x to the power of a divided by x to the power of b is equal to x to the power of a minus b. So if you apply that theorem, it becomes 8 to the power of 10 divided by 8 to the power of 8 square is equal to 8 to the power of 10 minus 2. Okay, that becomes 8 to the power of 8. What is this equal to? This is equal to 8 to the power of x. Okay, when two numbers becomes equal and and their bases are also same, then the powers obviously becomes the same. So what are their powers? 8 and here x. So 8 is equal to x, or x is equal to 8. 8 is equal to x. This is the answer. So the x in this problem is, this sum is 8. Okay, so let's take one more.
Evaluate the following.
Evaluate the following.
3 to the power of 4
Mm-hmm.
and 2 to the power of 6.
And 2 to the power of 6.
3 to the power of 4 is one question and 2 to the power of 6 is another question.
Okay. Okay. Fine. This is part A and part B. Yeah. Okay. 3 to the power of 4 is simple. 3 into 3 into 3 into 3. That is equal to 81. 3 3s are 9. 9 9s are 81. Similarly, 2 to the power of 6 is equal to 2 into 2 into 2 into 2 into 2 into 2. So 2 2s are 4, 4 2s are 8 here, and 8 here. 8 8s are 64. That is the answer. Okay. Let's take few more sums. Okay, so let's take another sum.
Write the following numbers. In scientific notation. Scientific notation.
Scientific notation.
The first part is 15.
First part is 15.
The second one is 150.
150.
And the third one is
Okay.
15,000.
15,000. Okay. So what is the scientific notation? Any number, if it is written in a into, any number that is written a into 10 to the power of n. Is it? Where any number that is written in this form, where a is between 1 and 10. Either it is equal to 1, okay, equal to 1, or more than 1, but it should be less than 10. Okay, and n is an integer. Okay, n belongs to an integer. It can be a positive number, it can be a negative number. Okay, so any number that is written in this form is called a scientific notation. Okay, so here the number that is given is 15. Can we say this is in the scientific notation? No, right? It is not in this form. We have to write this number in this form. Okay, so for that what we have to do is, we have to first write this number as something whose value is between 1 and 10. Okay, so whose value is between 1 and 10. Basically we have to divide this one so that we will get a number between 1 and 10. Okay, so what is that number that we should divide with? Okay, if I do that, 15 by 10, will I get 1? That division should only take place with the 10, 100, 1000, 10,000, so like that. Okay, it should only be divided by 10 to the power of some x, where x is a natural number. Okay, so what do I get if I multiply, if I do this operation 15 by 10, I'll get 1.5, isn't it? So here I'll get a whose value is 1.5. Fine. So since you divided this one, you should also multiply this one with 10. Is this number same? It is same, right? Because 10 gets cancelled, we are left with 15. Can we write it? We can write it, right? Okay. Why I divided this one with 10? Only if I divide with 10, I'll get a number between 1 and 10. If I divide with 100, what do I get? 0.15. That is why I don't want to divide with 100. Okay, so that's why I divided with 10. So if I divide with 10, I'll get 1.5 here, and this here 10 can be written as what? 10 to the power of 1. 10 to the power of 1. 10 can also be written as 10 to the power of 1. Okay, this is in scientific notation. 1.5 into 10 to the power of 1 is in scientific notation. We compare this one with this notation. A into 10 to the power of n. What is n here? 1. What is a here? 1.5. Okay. Okay. The very first thing, if some number is given, you have to multiply with something like 100, 110, 100,000 or 10,000. So such kind of numbers like 10 to the power of x number, where x is a natural number. So if I put 10 to the power of 1, I'll get 10. If I put 10 square, it is 100. If I put 10 cube, it becomes 1000. Okay, so I divided this one with some number, and at the same time I also multiplied with the same number. So the number will remain same, the 15 only. Whatever number is given here, we are left with 15 only. But I have written 15 as a scientific notation, where the end result is a into 10 to the power of a into 10 to the power of n. N is 1, a is 1.5. Okay, this is important. A should be between 1 and 10. It should be less than 10, but it can be 1 or more than 1. Okay. Okay, now let's take the other number, 150. 150. So the second part is 150. So I have to divide this one with some number. Only if I divide it, then I'll get a number between 1 and 10, isn't it? If I multiply with some number, I'll get more than 150. That's not what I wanted, right? That's not what I wanted. So 150, if I divide with 100, then only I'll get a number between 1 and 10. Again, the number here is 10 to the power of something, isn't it? 10 to the power of something. Why I divide with 100? I can as well divide with 75, or as well I can divide with 80. But why I chosen 100? Because I want to have some number here in the denominator which can be written as 10 to the power of something. So I got 100 here. If I divide with 100, then only I will get a 1.5, whose value is between 1 and 10. That's what I wanted, whose value is between 1 and 10. Because I divided this number with 100, I can also multiply this whole number with 100. Thereby 100 gets cancelled. I am still left with the same 150. Okay. Now if you simplify this one, I will get 1.5 here into 10. 100 can be written as 10 square. Now we got this in scientific notation. See, compare it here. A into 10 to the power of n here 2. What is n here? 2. Okay, is this a natural number? 2 is a natural number. It should not be 2.5, 2.5, 2.3, 2.7 or 12.5, 12.6. It should not be such numbers. It should be a natural number. Okay, it can be negative number like -2, -3, -4. Okay, it can be negative number also, but it should not be a decimal number. Okay, it should not be a decimal number. And here a is between 1 and 10. Here it is 1 and 10. Okay, it should not be 10, but it should be less than 10, but it can be 1. Okay, 1 less than or equal to a less than 10. Okay, so that's how we did the second one. So let's take the third part of the sum. So which is 15,000. I'm going to erase this one. So again, scientific notation is something that is written in a into 10 to the power of n, where a value lies between 1 and 10, and n belongs to a natural number. So what is the number that is given? 15,000. Okay, 15,000 is given. So what is the number that I should divide with, so that I get a number between 1 and 10? But the number that I am dividing with should be a 10 to the power of some number, 10 to the power of some natural number. Okay, so what is that number? It can be this one, isn't it? get 1.5. What is the number that I am dividing with? 10,000. So because I am dividing here, I need to multiply this also with the 10,000, so that this value is intact. The value that is given value is 15,000. That is intact. Okay. If you do something and if the value is changing, there is no point in writing, because we are writing the same number in scientific notation. The value should not change, but the way it is looking like is it differs. Here it is looking like a plain number. Here it should look like a scientific number. Okay. Scientific number especially useful if you want to represent a very big number. If you want to represent, then you have to use the scientific notation. Say for example, okay, let's do this one. Okay, so if I do this division, what do I get here? 1.5 into, this can be written as 10 to the power of, how many? 3 or 4? 3 or 4, 10 to the power of 4. Okay, 10 to the power of 4. If you evaluate this one, you will get 4 zeros after 1, not after 10. Okay, see here, we got this one in scientific notation again. Here the value is 1.5, which is between 1 and 10, and here we have 10 to the power of n, where n belongs to some natural number. Okay, so the scientific notation is especially useful if you want to represent a very big number. This scientific notation becomes handy. So here there are only 3 zeros, which you can easily write it. For example, if there are 70 zeros, what will you do? 70 zeros, what will you do? The same thing we should apply here. Okay? Same thing. Let's do it. Say for example, 70 zeros are here. There are 70 zeros. How can we write that number in scientific notation? 70 zeros. How can we write it? So, I'm going to write 15 0 0 0 0 like this, 70 zeros. I'm going to divide this one with, there are 70 zeros here. So including this one, there are 71. Including this 5, there are 71. So if I have to get a 1.5 here, I should divide this one with 10 to the power of 71. Okay? I should divide with, so that the decimal point will move and it comes here. Okay, yeah, so 70 zeros here, if a number something like this. So since we are dividing this one with 10 to the power of 71, we should also multiply with the 10 to the power of 71, so that this value remains intact. So this can be written as 1.5. If I divide this one with this one, I will get 1.5 into 10 to the power of 71. See how simple it is to write such a big number. 70 zeros, can anybody write on the board? Can anybody write on the notebook? Can anybody print on the textbook? It's not at all possible. Okay, even if you write, it's difficult to remember, it's difficult to read out. Okay, if some textbook is written such a big number, how much time it takes for you to read out? Okay, forget about how to pronounce that number. It is so big number, so it becomes trillions of trillions and all. Forget about that. But even to read out, to figure it out how many zeros are there, it is so difficult. It's a very massive task. So that is why you are relying on scientific notation. So this way, our life is become very easy. We simply put 71 here. And we simply put some number between 1 and 10. That's how these scientific numbers are becomes handy, especially in science, physics and chemistry, where the quantities are very small, or the quantities are very big. For example, the celestial bodies are very big, whereas the electrons, protons, neutrons, they are very small. Okay, so especially to deal with the minute quantities or the very huge quantities. Okay, let's take one more and finish this session for today.
Without using a calculator, evaluate the following.
Divide the following, is it?
Evaluate.
Evaluate the following.
3 to the power of 4. 5 to the power of 3. 3 to the power of 4 is one question and 5 to the power of 3 is another question. And minus 3 to the power of 4.
Minus 3 to the power of 4.
Minus 3, not minus
Sorry,
5.
minus 3 to the power of 4.
Yes, that's it.
Okay, so there are 3 numbers. Okay, it's fairly simple. 3 to the power of 4 is 3 into 3 into 3 into 3. Sorry, which is 3. Which is 3 3s are 9, 9 9s are 81. That is simple. 5 cube is 5 into 5 into 5. 5 5s are 25, 25 5s are 125. Minus 3 to the power of 4, which is equal to minus 3 into minus 3 into minus 3 into minus 3. Minus minus, minus into minus is plus, plus into minus is minus, minus into plus, minus into minus is plus. Okay, if a number with minus, or if a minus is multiplied even number of times, then you will get a plus. If a minus is multiplied odd number of times, you will get a minus. Because how many times we are multiplying minus here? Minus into minus into minus into minus 4 times. Okay, which is an even number. So you will get a plus. 3 into 3, 9. 9 9s are 81. Okay, let's take one more sum. Okay, the other sum is 6.12 into 10 to the power of 1. Evaluate this number. So when we evaluate this one, what is it? 10 to the power of 1 is equal to 10. So anything x to the power of 1 is equal to x. Okay, n to the power of 1 is equal to n. So 6.12 into 10 to the power of 1 is 10. It's not 1. What is 1? 10 to the power of 0 is 1. X to the power of 0 is 1. Okay, don't be confused with that one. 6.12 into 10. So if I multiply this one, 6.12 into 10, how does this decimal move? Because we are multiplying with the with the 10, the decimal point will move to the right side. Okay, 61.2. That is one thing. And second sum, what we take here. Okay, so let us also evaluate this expression having 4 numbers in indices form, 2 in numerator and 2 in denominator. Okay, the ones in the numerator getting multiplied and the ones in the denominator also getting multiplied. Okay, so let's evaluate this one. Let's simplify this one. One thing, for each of these are having a base same. Okay, here we have base 7, 7, 7, 7. Okay, so if you want to simplify this numerator, what is that? This is in the form of x to the power of a into x to the power of b. When you evaluate this one, you will get 7 to the power of x to the power of a plus b, 3 plus 5. And the down here, on the denominator, what is this? 7 to the power of 1. 7 can be written as 7 to the power of 1, isn't it? 7 can be written as 7 to the power of 1. Here 7 square. What do we do with this minus? Minus. You can take it out because here you can say plus, here you can say minus. Okay, minus is already here. If there is nothing, plus. Plus into minus is minus. Minus 7 to the power of 1 into 7 square. That gives you 7 to the power of 1 plus 2. Okay. That is equal to 7 to the power of 3 plus 5, which is 8, by 7 to the power of minus 7 to the power of 1 plus 2, which is 3. That is equal to plus by minus. Plus by minus. What is that? It's a minus. Plus by minus is minus. Minus by minus is plus. Okay, 7 to the power of 7 to the power of 8 minus 3. That is equal to minus 7 to the power of 5. Minus 7 to the power of 5. Okay, the signs here is nothing to do with this what we are evaluating. Okay, because this is separate. This is not part of the indices number. That is not part of the indices number. What is the indices number here? 7 square is the indices number. What is the indices number here? 7 to the power of 1. If something is written like 7 minus 7 4 to the power of 5, then this minus is a part of the indices number. Okay, in that case you have to consider minus also while evaluating the power 5. But here minus is outside this number, you can say. Okay, that is why I brought this outside, and here plus by minus, which is minus 8 minus 3 is equal to 5. Minus 7 to the power of 5. That is the answer when I simplify this whole expression, the given expression. Okay. Alright, yeah, we'll end this one for now and we'll meet up again in some other class. Thank you.